Thank you so much, and welcome everyone to the HAPS Alliance Summit. It's my distinct honor and pleasure to be your host throughout today's session, and I'd like to take us through today's agenda. We have, as Matt said, many great sessions for you during this webinar today. We will first hear from Ken Riordan, who's the president of HAPS Alliance, in just a moment. We will have Ryuji Wakikawa from SoftBank and HAPSMobile talking about 6G Concept and HAPS NTN. We will then go through a HAPS Alliance member use case on HAPS for methane monitoring. We will hear from the working group chairs of the HAPS Alliance and understand what's going on there. We will then have a moderated session on HAPS action against wildfires with 4 speakers. And then we'll have some segments as well from various member companies of the HAPS Alliance also working in that space. And then finally, we'll have closing remarks from Greg Ewert, who is the Vice President of HAPS Alliance. And I think with that, I will go ahead and introduce Ken Riordan, who is the president of HAPS Alliance, also head of product management, connectivity solutions at Loon. Welcome, Ken.
Thank you, Alicia. And hello to everyone who's joining us today. Really looking forward to this. It would be better still if we could be together face to face. But we'll do our best with Zoom today. We have people joining from all over the world today. I myself am looking out the window in my Chicago area home. If you're wondering, it's cold here, but it's a bright sunny day. We're joined today by both members of the HAPS Alliance and individuals not yet members. We have, I think, a great agenda in store for you today. We think you'll be both inspired and informed. And if following today's session, your company is interested in learning more and perhaps joining the HAPS Alliance, we certainly will provide the information for you to look into that, and we can explore that together. To kick us off today, I wanted to share a couple of personal reflections. The first is, as Alicia mentioned, my company Loon, as you may be aware, announced earlier in this year its intentions to wind down operations, and I want to touch a little bit on that. The work that Loon had done over the nearly decade of uphill accomplishments, we took this decision fully expecting that others will carry the torch of high altitude platform technology forward, and the HAPS Alliance, we believe, is central to that. But Alphabet, our parent company, to allow the HAPS Alliance and allow its other member companies to move forward successfully. I'll just give you a few examples. Loon has made its high altitude platform patent portfolio available to partners. We have open sourced significant amounts of monitoring and environmental data that was collected in the stratosphere over millions of miles of flight in the stratosphere. And most recently, we have made available hundreds of pages of key innovations and key learnings in a work that's called the Loon Library. And this work is available for all to consume on the Alphabet website. For those of you who are members of the Alliance, we'll be together tomorrow in a members only session, and colleagues of mine from Loon will be with us, and we'll talk in much more detail about the Loon Library and how that can be utilized by members and non-members alike. My second story that I'd like to share with you all this morning it is a bit more personal. One of my immediate family members was very recently diagnosed with a very serious illness, and one of the things that a family does in a situation like that, of course, is to go to the internet and learn what we can learn about the disease, and learn what we can learn about various treatment options. And the ability to do that is something that in the developed world we take for granted. It's part of how we get along. And in these times, I have reflected on what a privilege that is, to have that capability, and I think about people in undeveloped parts of the world that don't have that privilege, don't have internet connectivity, and really it gives me pause to think about facing such a personal challenge without the capabilities to reach out and interact with others and gain information. So it really is a very humbling thought. What I can tell you all is that the HAPS Alliance and our member companies, we're working every day to do something about this challenge faced by the billions of people that don't have internet connectivity. Our member companies are making great advancements every day. Advancements in aircraft technology, in telecommunications technologies, great work in antenna capabilities. But we're doing this, I can also tell you, we're not doing this in a vacuum. We firmly believe that for HAPS technologies to achieve wide-scale commercial success, that it will be necessary for HAPS to exist in a heterogeneous network of land, sky, and space assets. So we're working with many key partners that have expertise in satellite technology, expertise in terrestrial networking, to ensure that HAPS is part of this overall heterogeneous new world that we are working as an alliance to help create. So we have great speakers lined up that are going to talk about the work that they're doing in the HAPS space. So I will not hear from these colleagues. So with those remarks, I'll stop here. Very much hope that you'll enjoy what you'll hear throughout today, and for HAPS Alliance members, look forward to being with you tomorrow. Thank you very much.
Thank you so much, Ken. I appreciate your remarks. I'd like to now turn the stage over to Ryuji Wakikawa. He is Vice President, Head of Advanced Technology Division of SoftBank Corporation. He sits on the Board of Directors for HAPSMobile, and he also sits on the Executive Board for HAPS Alliance. Ryuji, welcome.
Thank you, Alicia, for the introductions, and also great introductions from Ken. And we have been working together on this subject for almost a few years. And today's my presentation is about HAPS for the network. I know HAPS can be used for the multiple use case, but I particularly focus on the network. All right, I tried to press the next button, but didn't work. Okay. Oh yeah, here you go. All right, let's try the next buttons.
Stand by just a moment, Ryuji. I'll get that taken care of
Yeah,
for
sure.
you.
All right, I seem like Alicia already covered my introduction, so let's skip this. So we just begun this 5G deployment, but in operators, like we have started like beyond 5G or 6G, like R&D already. And our visions regarding like beyond 5G is like infrastructure for the fully digitalized society. So it's a very like conceptual, but and this is how like we define the beyond 5G. And here's like today's network infrastructure. Like you probably very familiar with. It's like there are like bunch of like base stations and serving the also like mobile phone and the phone services, and you know, some internet service over the smartphone. In the next infrastructure is going to be like a totally changed. Like there's a base station, of course, but there's HAPS and satellite and covering more like wider coverage. And this infrastructure is supporting like a multiple like industry, enterprise, consumer services, and us and society, like education's net zero. So, and this is not only for the mobile. There's like a wireline has to be converged because like enormous data will be generated. So radio is not the only solution. So it's going to be very combined various like mobile technology and the wireline technology. And we have like defined the 12 challenges for 6Gs. I can speak like 2 hours by this subject, so I'm not going to do this. But there's like a press release from the SoftBank regarding like this 12 challenge. So you can Google the SoftBank like 6G, then you can see some detail like descriptions. But there's like NTN and HAPS, which is the area expansion. This is a very, very important subject towards the 6G. So I'm going to cover this. And before like, you know, probably like beyond 5G, 6G or 5G, like a future mobile network, like there's one global digital infrastructure, which is the internet. So basically like the next like infrastructure, next mobile infrastructure is similar to like what the internet is offering. So the mobile network, maybe like our 5G, beyond 5G, 6G network will be converged into the internet and serving the multiple different like industry. And there's a 4G, 5G, 6G, or like a fixed wireless and HAPS and satellites in underline. So this is our concept. And regarding like area expansions, you know, like before 5G, this network is only for the smartphone and phone people. So we just like provide a coverage where the people are living. However, like next like agenda for the mobile network is like every devices, everything. So IoT, you know, there might be like some drones in the airspace. So we need a coverage in the airspace. And also like, you know, the rural, where the people are not living there, but we probably need to provide a connectivity. So from like a population coverage to the land coverage, this concept change is very, very important. And we anticipate like this HAPS platform for doing this. I'm going to show you like some video.
Throughout history, we have ventured into new territories. We have reached and explored outer space, but not the stratosphere. In 2017, SoftBank established HAPSMobile and set off on a journey to the stratosphere. For what purpose? For the internet. With the widespread expansion of mobile devices, we now use the internet whenever and wherever we like. But half of the world still does not have access to the internet. So for the future, HAPSMobile will take up the challenge of building a stratospheric telecommunication platform system, HAPS. HAPS is an unmanned aircraft system equipped with a mobile base station. It uses solar power to fly in the stratosphere. With this aircraft transmitting radio waves from 20 kilometers up in the sky, it can cover an area with a diameter of 200 kilometers. This coverage is equivalent to about 400 base station towers on land. HAPS's big advantage is that people can use the mobile devices that they normally use. Along with smartphones, HAPS can even be used for low-priced and energy-efficient IoT chipsets. Unlike satellite communications that require dedicated equipment, existing 5G and LTE can be used as is. With today's communication infrastructure, there is no internet where there are no people. But there are IoT devices, observation sensors, and cameras that are waiting to be connected. Imagine this: a future with HAPS aircraft flying above us, covering wide areas, resistant to disasters. The internet is a core infrastructure, just like water, gas, and electricity. We're on a mission to make the technology accessible for everyone. We will continue to take on the challenge of developing the future of mobile communications to deliver internet connectivity across the entire world.
So this is a concept of like a HAPS, how we leverage the HAPS platform. So internet from the sky. So HAPS is actually one of it. Where SoftBank has invested in OneWeb, which is a LEO satellite communication company. And also like we have a Sceye as a portfolio of the SoftBank investment. And Sceye is a geo satellite company providing the connectivity to the IoT devices. So it's going to be combinations. And combinations of like these satellite and HAPS, and they are really complementary solution. They are not like competing each other. It's going to be complementary. Depending on the use case, we use the best infrastructure. And what's the difference? What's the difference between the satellite and HAPS? It's all about the mobile dialect. HAPS is a very, HAPS solution is a stratosphere, which is 20 kilometers from the ground, which is very, very close to the ground. It can achieve like a very low latency, like 0.3 millisecond one-way latency. So this actually like enable like a 5G or like a 6G service offering from the sky. While like a LEO satellite, it's still like closer than the geo satellite, but still like more than 1,000 kilometers far away. So the latency wise is a little bit longer, which is very difficult to provide a 5G through the LEO satellite. But still like, they use a dedicated spectrum for the satellite and providing the wider coverage. And also the difference is deployment approach. The HAPS, one airplane can serve the particular locations and providing the coverage. While like a LEO satellite, it's required constellations. So for example, like OneWeb plan to launch more than 600 satellite, and the SpaceX as well. So it has to launch hundreds of the satellite at once, and every 6 to 10 years they have to relaunch because the battery will be running out and every small satellite. So they're very capex heavy. But anyway, we were gonna mix these.
HAPSMobile uses an aircraft equipped with a mobile base station that is designed to fly for several months. Using lightweight carbon materials, it can fly even with little wind. With a total wingspan of about 78 meters, it can also withstand turbulence. The wings house solar panels, while the aircraft is equipped with high-performance batteries. During the day, the aircraft flies, while solar panels charge the batteries. During the night, the aircraft continues to fly off the charged batteries. The aircraft does not use any fossil fuels, making it completely sustainable. Given these technologies, we predicted the aircraft could fly for 24 hours, and that is why we started the HAPS business. The onboard computer automatically controls the aircraft according to wind patterns. The simple wing-based design improves aerodynamic performance and also makes mass production possible. During takeoff, the aircraft follows guidance from the Airport Takeoff and Landing Center. It flies in circles to increase its altitude. When it reaches the stratosphere, a globally managed operation system directs the aircraft to a specific service location. Once it arrives at its service location, the aircraft flies continuously on autopilot for several months, delivering internet connectivity to the ground. The aircraft's design makes it possible to switch or replace systems as necessary. This makes it compatible with LTE, 5G, and all other types of base stations. The aircraft can also house sensors and cameras. In 2019, 2 years after we started the design process, the aircraft cleared NASA's safety review tests and succeeded in its first flight. The aircraft will soon be flying in different parts of the world. A connected world is right around the corner.
Yeah, so this is about like our airplane. Sorry, I just hit the next button like accidentally and start the video, but this is about our airplane. I have some video for that flight. Okay, so during like this experimentations, we have tested our payload, and this airplane can carry like more than 10 kilo, even more like a bigger payload. And we have a collaboration with Loon for this payload, and this time like LTE. And the left upper like is a feeder link, ground stations, and we did a successful video call through our airplane. And then you see like a Vinsar from Google and Jim Lai from Keio University and Alista from Loon. So Vint and Jun are kind of like a legend of the internet. So we are very like, this was a very important day for us. Like, you know, we finally like did, technology proof about the HAPS, and we celebrate that day with two legends of the internet. And this like mobile operation is all about like standardization. Spectrum is very regulated in each country, so we have decided to start some standardization activity regarding the spectrum. The feeder link, which is a backhaul of the HAPS platform, there's like a lot of like frequencies is already allocated and addressed. So you can start any experimentations using these frequencies. However, like a service link for the mobile data, this spectrum has to be really like addressed in WRC, which is ITU meeting in every 4 years. In 2019, WRC 19, through the Japanese government, we have submit the proposal expanding the ISM spectrum for service link from the stratosphere, and this agenda was approved, and which means like from 19 to the next meeting is going to be 2023. So next 4 years, like we have been discussing like in the meeting and get seeking the approval in 2023. So beyond the 2023, if we can successfully get the approval, many of like spectrum can be used for the service link from the HAPS. I think that will be the very key milestone for this HAPS Alliance as well. And the market potential by country. So this 60% is where like a mobile operator is providing the coverage to the land, against the land. So Japan is 60%, Indonesia is like 28%, Australia is just 25%. Many of the lands are still like uncovered, which we try to solve by this HAPS platform, and maybe like a satellite as well as a complementary. So anyway, our mission is the deliver the internet connectivity to everywhere. So that's like our concept, and we believe like we can make this happen very soon. Thank you so much.
Thank you so much, Ryuji. I do have a few questions from the audience, and just a reminder for anyone that might have questions to please put them into the question and answer period. So if we have a few minutes, first one is really around timing, when you anticipate commercializing HAPS services.
So HAPSMobile currently like saying like 2027. So probably like 4 to 5 years. I feel like we can do a lot of experimentation before that. But for the commercializations, we need a kind of like clearance of the aircraft type certificate, and we probably need to define the kind of like regulations for the airplane operations, crossing border, and so on. So, and also like a spectrum is going to be defined 2023 and beyond. So I think the best like guess is going to be like 27. But with the kind of like government approval, I think like we can do some kind of like experimentations or like pre-commercial in some country.
Very good, thank you. Could you comment on how payload issues being addressed? For example, 0.75 millimeter wingspan can lift 5 kilograms of payload, which is far below the feasibility point, as an example. Just wondering if you can comment on the payload issue.
Yeah, I'm not sure like if we officially like a state like how much payload we can carry by this aircraft, but our aircraft can carry much more than 5 kg. So, and this airplane is originally designed to carry the base station. So actually before the airplane designing, we have a target payload weight. And to carry that payload weight, the airplane becomes bigger, like 78 meters. So we have like enough payload capacity and weight for the base stations.
Very good. What challenges do you need to overcome before providing commercial HAPS services?
I think the biggest challenge is it's really not the technology, but more like regulations and kind of like a market acceptance. Because this like HAPS sounds like really crazy, I admit, but I feel like a technology is proven. So I think the market acceptance, which means like operator has to really like understand this technology, and every time like the new stuff is very challenging. But I feel like we need to overcome that like a challenge, and also regulations, which require the kind of like these ecosystem, and also this HAPS Alliance will be serve like a very important role for the regulations and the standardizations.
Thank you, Ryuji. A little bit of a follow-up question to that regarding what prevented you from demonstrating staying at the stratosphere during the night?
So during the night, so what was the questions? Like how the airplane served during Japan, during night?
It's a question that's coming from our socio audience, and it says, what prevented you from demonstrating staying at the stratosphere during the night?
Staying, what's a staying?
Well, and from our video, we saw that it did run on the solar power through the night. So I'm not quite sure.
Okay. So,
yeah.
So the airplane has a battery. So the airplane charges the battery through the solar panel at the daytime, and at the nighttime, airplane just use the battery power for the operations. So and this a cycle, it depends on battery charging cycle, but we expect at least 6 months airplane can stay in the stratosphere.
Very good, thank you. Two-part question here. Does HAPS have unique test cases that need to be done pre-flight and remote in-flight using remote diagnostics, and will those test cases be standardized per HAPS Alliance requirements? And then additionally, do you see a need for digital twin simulations that start as all software, but then migrate to hardware in the loop and software in the loop?
Yeah, definitely. First questions, there's we don't have any particular use case. I think we have to develop for that. When we did the flight test, we got help from NASA and Armstrong and team, and we did all the clearance and then test flight. But I still we need a guideline for future test flight, and also a digital twin. I think the photogrammetry technology is very progress, and by using the photos, you can make the 3D model easy, and also if you can map the data from the sensors, and maybe these data will be collected by HAPS. If these data can be mapped on these a 3D modeling, it's really coming to these a digital twin world. And I think this HAPS infrastructure will be very important role for these digital twin and software.
Thanks, Ryuji. A question again from the audience here. Can you please share any stats on LTE testing with concurrent users? For example, how many concurrent voice users, how many concurrent video call users, kind of getting to what the overall capacity of a HAPS?
Yeah, so I think it depends on how the payload will be defined. By the way, we are not doing the operation yet. So I believe the question is about the performance of the payload. But I think it depends how many sectors we will add in the payload. So currently I think the 2 sectors are added in our experimental payload, but we plan to increase to 7 sectors. So 7 base station is actually integrated in the payload, which means providing the more capacity to the ground. I'm not going to in detail on these a number.
Okay, fair enough. Are there already HAPS in service in Japan? And if not, what's the obstacle? And you talked a little bit about timing early on, but is that timing specific to Japan, or will they'll be testing there sooner?
Japan is Japan is very located in the north, which is challenging because solar panel and the battery performance. It's about all about a solar and the battery. So how much power we can generate at the daytime, and how much power we can store in the battery. Because if the battery is, we add the more batteries, which means like more weight. So this is all like a trade-off. And Japan is a little bit like too north, and we need to wait for the more advancement of the solar panel and the battery technology. That's why like a SoftBank has been like working on the battery development also for the HAPS in Japan.
Thanks, Ryuji. Question, have you considered a helium or hydrogen-filled blimp HAPS? Why or why not, and why did you choose the airplane type of technology over the lighter than air aircraft?
Oh, that's a good question. We are like developing this airplane because there's no airplane which we can use in the market when like we have started 4 years ago. But the HAPSMobile is, SoftBank is operators. So our interest is not like developing the airplane. So if there's like a practical airplane which we can run the mobile network operations, we are allowed to use these. So I think like that's a very, very important because like thanks for the HAPS Alliance, we know like a lot of like new companies, new technology for the HAPS. And I believe like, it's cost and performance. And, these are kind of like a key metric. So if there's a good technology coming up for the HAPS, yeah, we love to test these.
Great, thank you. SoftBank is working with OneWeb and other satellite communications providers. How will your HAPS service coexist with and complement satellite-based services?
So satellite-based, OneWeb can start like commercializations much earlier than the HAPS. I think like they can start like the services sometime like next year. And after like we finish launching those satellite. And so the time is different. And also like in the long run, OneWeb is good for the kind of like airplane or ships, which moves very widely. While like a HAPS, it's like a 200-kilometer diameter is a super wide area, but still like it's good for the IoT sensors and small devices which can carry the mobile chipset. And also the feeder link for the HAPS, we locate the ground stations on a gateway on a feeder link on the ground. But in the long run, this HAPS platform can use our OneWeb as a feeder link for backup link. Of course, it's not always, but if there's some issue, problem or error in the feeder link, it can switch to the OneWeb and continue providing the connectivity and so on. So HAPS can be kind of like a base station, transform the satellite spectrum to the ISM spectrum. So like providing the mobile dialect, that kind of like usage can be also like considered in the future.
Thank you so much, Ryuji. I do have a few more questions, but I think that our time is ending. So thank you, audience, for all of your terrific questions. If I didn't get to yours, certainly we can do some follow-ups with Ryuji later by email. But thank you, Ryuji, so much for that really informative session.
Thank you so much.
I'd like to turn now and get to a really interesting use case within the HAPS Alliance work that's been done. And this is Sceye speaking to us about HAPS for methane monitoring. And with us today is Mikkel Vestergaard. He is the Chief Executive Officer from Sceye. So welcome, Mikkel. I will turn the stage over to you.
Yeah, thank you very much. This is Sceye 1. This is an actual HAPS platform that we have built and flown. We build and fly several, at least more than one every year. And I think a picture is important for us to show because historically, there has been a lot of talk about building stratospheric platforms or HAPS. but historically, very little other than PowerPoint presentations has been built, and it's only in the last decade that we've seen a change in that. This photo is taken in New Mexico, where we have our hangar for final assembly and flight right outside of Roswell. This is a video from a flight that we had in November last year. It's also on our website, and I'll encourage you to go and see it, but at the interest of time, I will skip it here, but I promise you it's not boring. This will be 3 minutes well spent. We have been flying regularly since 2016. We were founded in 2014, have been flying regularly since 2016. Started small and with a 9-foot model that couldn't even lift its own weight. So we sent it with a balloon into the stratosphere, but just to start generating data. But the point here really is using a iterative development model or continuous development to start small, build slightly larger, flying higher and higher with more and more capability. And so from the 9-foot moving on to a 70-foot version that flew between 10 and 20,000 feet. And in 2019, we were flying around the jet stream, giving the pilots some stick time and learning a lot, both about our aircraft and about ground operations. And in 2020, we flew the one that you saw in the previous pictures. Didn't make it all the way to the stratosphere. We boarded in 40-some thousand feet because we had a misalignment in our gas management system. But in May of this year, we made it to our target altitude of 65,000 feet, or 64,680 to be precise, and already in production with the next 2 vehicles that are functioning as product demonstrations for customers. Also, 2 weeks ago, we connected a massive MIMO array with 3D beamforming directly to smartphones on the ground in both directions, up and down. So yeah, we have effectively documented what we said we would do. This was with a radius of 140 kilometers or diameter of 280, close to 300 kilometers. But telecommunications is not all we aim to do, and we work closely with the European Space Agency over several years to define and review a payload package for methane monitoring. And we've done that in partnerships with ABB, GMB, the Royal Dutch Meteorological Institute, and a few others. But the rationale for European Space Agency to want to be involved here is, in spite of them having their own methane monitoring satellites, and quite capable. I mean, they're probably best in class today, the Sentinel-5. But they can see methane with a pixel of 7 by 7 kilometers. From the stratosphere, we can see methane with a pixel of 1 by 1 meter, or sub 1 by 1 meter. And that means that we can see the difference between, is it this pipeline that's leaking, or is it the cow standing next to it? And because we are geostationary, we can see the rate of emission. And that's really relevant, and that's entirely new, because that gives us a couple of things we've never had before in the arsenal. Number one, it allows for regulators to both improve on regulation, but also enforce it. Two, the weakest point in the Paris Accord is self-reporting. And by being able to see the specific emitter, whether that's at individual level or factory level or city level, and scaling that up to national level, and seeing that in real time, we're suddenly in a position to remove the weakest link from the Paris Accord, and that should be interesting to all of us. We've classified here, based on the gases that we're observing, the various instruments that we pre-qualified together with ABB, and a picture emerged for ESA that was quite clear, that the lighter than air platform is significantly more capable than the heavier than air platform for methane monitoring, simply because of the need to lift significant swamp. And so moving on to something that is starting to become implementable, the New Mexico Environmental Department has, a couple of months ago, that was in August, signed an MOU with US EPA with a specific purpose of using Sceye HAPS to monitor methane over the Permian Basin. And so they're doing that both because they are interested in the general air quality in the state, but also because they're acutely aware that that they have not previously had the ability to regulate methane leaks to the extent that was required, whether that was with handheld devices on ground, whether that was from Cessnas, or whether that was from satellites. And so as we look to the future with a platform that has a lifting and powering capacity that's significant, and as we have geostationary capability, we're opening up to being a multi-tenant platform and a multi-use platform. Because if we're looking at services such as methane monitoring, and for that matter, wildfire monitoring and early detection as well, we'll be flying with infrared, with LiDAR, with multispectral imaging, and with optical equipment. And the things that you can do if you fly with a payload package like that, and I'm not talking one instrument at a time, but all four together, the things that you can do with a package like that is actually quite significant. So, so the thought of HAPS as a multi-tenant platform for the future is the picture that I want to leave you guys with. Thank you so much for listening.
Mikkel, thank you so much. Really interesting material. I will move us on fairly quickly in order to stay on track with our busy session today. Wanting to give you just a quick overview from our working group chairs that have all been busy with their groups. Let me move to the next slide. This is something that we can find on the HAPS Alliance website, but it's a quick view of the organization and how it works, and you will see, I'll get into a little bit more detail of the 4 working groups that are currently active in the HAPS Alliance. And each of, actually the top 3 will give you an update. The 4th, the Applications Task Force, is just being formed now, but the Aviation Working Group co-chair will be speaking with us, Andy Thurling. He is a consultant at HAPSMobile SoftBank. He will be followed by our Telecommunications Working Group Chair, Fatema Hamdani. She is co-founder and CEO at Kraus Hamdani Aerospace. And then we also have Matthew Nicholson, Corporate Communications Deputy Manager at SoftBank Corp, leading the Marketing Communications Working Group. So I will turn it over to the 3 of them. I believe we are starting with Andy Thurling to give us an update on the Aviation Working Group.
Great, thanks very much. Let me see if Pickle works for me. There we go. So we'll start off with the Aviation Working Group. I'm Andy Thurling, representing SoftBank and HAPSMobile as a co-chair. With me is Tim Downs from Airbus as my co-chair. The mission of the Aviation Working Group is that, and there's been some questions, you know, from Ryuji's briefing this morning already about the aviation regulations and technologies and being in place to support HAPS. And so we admit that there is that the current ecosystem doesn't really support HAPS very well, and so that's what the aviation, one of the tasks of the Aviation Working Group is to advance the aviation regulations, ConOps, and technologies, as well as standards to foster the growth of the HAPS industry. We need to communicate on the HAPS ecosystem vision and educate other people in the industry and regulators on HAPS needs. And we do this by focusing on, well, first of all, development of a new traffic management paradigm for the stratosphere in terms of a more collaborative traffic separation rather than a highly controlled traffic system as we have in traditional air traffic management. We also need to look towards risk-based safety frameworks for HAPS and advance the HAPS certification and the develop concepts for scalable operations. This includes automation certification. Many of these things, many of these new entrants in terms of HAPS and advanced air mobility, UTM of drones down low, they don't really scale well without accepting higher levels of automation in the system. And of course, this means new concepts for human-machine teaming. Some of the things that we've been delivering are white papers to do that communication, speaking at conferences, and recommendations to standards bodies and other regulatory agencies, and I will go into that in a little bit. In 2021 achievements, you know, back in 2020 with the pandemic, we were first formed. We started looking for our destination, then creating a map, figuring out how we wanted to get there, and then finding that compass. So many thanks to Leo Bouygues from Loon for getting us started. He was the initial chairman of this aviation working group, and now we're in full on run mode. So one of the things we have done is we've started that communication. We've started that socialization of the HAPS concept with a very important stakeholder in this ecosystem, which is the air traffic management community. And we did a presentation at the World ATM Congress just this past October. And we published a terminology paper, which is seeking to go out and start to define how HAPS are thought of by us, and by publishing the paper to communicate with our regulatory agencies. Also looking to operations at scale white paper, similar kind of concept where we're defining how we see ourselves in the future, not necessarily the close future, but in the mid to far future, how we see the HAPS evolving, and use this as a tool to communicate with regulators, help steering their short-term regulatory decisions so that we can enable that longer-term vision. One of the big things that we need to do in that regard, and I think that you know, some of the HAPS Alliance members will have a treat to discuss this tomorrow with our friends from Loon on how we really need, as we move into that more collaborative, more of that autonomous fleet management system that we are going to describe for the stratosphere, that we need to start thinking about how the humans and the machines team more differently than the very focused remote pilot in command concept that we have for manned aviation that we have been with for over 100 years. So big chance to change paradigms there. On that topic, communications white paper is in approval right now for 2022. We continue to participate with world bodies looking to contribute our flight data into the World Meteorological Organization. The JARIS, which is the Joint Authorities on Rulemaking for Unmanned Systems, is regulators from over 63 countries now, and we're engaging with them to try and shift that perception among the regulatory bodies. NASA has a multi-aircraft operations, or some people say M to N, where M is a small team of M humans managing N, you know, highly autonomous vehicles in the stratosphere. Also NASA, some individual HAPS Alliance members are collaborating with NASA and the FAA on what they're calling their ETM, or the traffic management for upper class E. Similarly, ECHO, which is a Eurocontrol program in Europe, is also underway, looking to do similar things from a European perspective. And we're in discussions with the executive board now to actually get a HAPS Alliance representative, rather than just individual companies participating, but an actual HAPS Alliance person sitting on that advisory board. So look for that in the future. Along with continued engagement with the ATM community, the air traffic management community, we're working on a paper for the Journal of Air Traffic Control for the spring, and a presentation in May at their technical symposium to continue that dialogue, continue changing the paradigm of how we think about control of these vehicles once they're in the stratosphere. We continue to work the risk analysis framework with our partners at Air Services Australia, who have been instrumental in pioneering this kind of concept, and looking to continue work on our final white paper, which is a discussion of how we can create new means of compliance to the performance-based requirements for certification that we have been advocating for HAPS. With that, I believe I am done, and I can hand it over to Fatema.
Thank you, Andy. Appreciate it. I'm hoping everybody can hear me. So moving to, and it's good morning here at my end, California, San Francisco. As Andy mentioned, we are running the telecommunication group, and essentially some of the things that we are focused on is regulatory bodies within the telecommunication, as well as how can we be participating globally across the board with various different regulatory bodies, such as ITUR, which is the International Telecommunication Union, radio communication sector, as well as the third generation partnership project, 3GPP, which are all kind of coming together from a telecommunication perspective, and HAPS playing a role across in that, and standards for that. In addition, as the HAPS Alliance mandate kind of increases, looking at various different altitudes and how HAPS kind of enables different altitudes as they play a role in the telecommunications space and effective telecommunications solution. We're also partnering with other bodies such as the Telecom Infra project, which was originally started with Facebook and has a number of members as well, to bring in attention on what is needed for telecommunication to become mainstream, utilizing HAPS assets. Some of the achievements for 2021 have been, we actually had Deutsche Telekom come in, who's one of the HAPS Alliance members, present what their experiment within the HAPS did, and actual facts and figures of flying an HAPS asset so that they could provide telecommunication. In addition, what we're looking to do is promote other members who are continuing to test out technologies to come in and actually present to the members viability business cases, because some of the questions that came up when Ryuji was presenting was exactly around, hey, how will this become viable? How are all the technologies coming together? And so that's why actually having member companies come and present in what has been achieved has been really successful for us. In addition, we've been actually creating presence at these various different organizations and standard bodies to make sure that HAPS is treated as a viable solution and is part of the conversation as we go and look beyond 5G as well as 6G. In addition, business case and writing up white papers to actually see the viability of HAPS and the non-terrestrial networks, as folks are talking about, and how all of these come together in terms of communication. So the telecommunication group is really focusing in on bringing and having the conversation around various architectures, various coexistent aspects of different altitudes, including ground and other non-terrestrial networks, and how all of these will come together, whether that be last mile uplink, backhaul of data, and then obviously telecommunication pieces around that as well. And finally, looking ahead, what some of the things that we're focusing on is actually publishing a white paper that furthers this information, brings in various different components from all the different altitudes, as well as satellite providers, and how the overall architecture, standardizations, antenna conversations are all happening across various different providers in the market space. So that's something that the telecommunication group will be focusing, and any input from the members coming in will be brought in through the white paper that we're looking to publish. In addition, focus on 6G is becoming quite heavy as well. My co-chair is Shiro from SoftBank, and so we're really working together to kind of bring visibility on how 6G or 5G and beyond 5G use cases will be supported in as HAPS becomes a reality within the telecommunication space, as well as partnering with actual telcos. We have several telecommunication companies such as Deutsche Telekom, T-Mobile, that are already part of HAPS Alliance. So we're kind of creating an entire ecosystem of HAPS developers, telecommunication, HAPS users, to truly ensure that when we are accounting for HAPS as a telecommunication asset, that we're bringing in everybody's input in and standardization from a technology development across the entire spectrum. And so those are some of the things that we as the telecommunication working group are very specifically focused on. And on that note, I will hand it off to Matthew Nicholson for the marketing and communication working group.
Thank you, Fatema. I'm Matthew Nicholson, and I'm chair of the Marketing Communications Working Group. Just in a nutshell, our mission is to use marketing and communications to raise the profile of HAPS, the HAPS industry, the potential of the stratosphere. And we also, one of our missions is to help foster a community and an ecosystem among the industry. So just to touch upon some of the highlights so far, when we started in 2020, we were about 12 companies altogether at launch, and in part with various recruiting activities, we're now at about 44 companies at the start of November. So the community is growing. In April, we held our first member meeting. It's the first time for all members to come together virtually. And in August, we published our second white paper, which is really a showcase for the activities of Alliance members. We also work to promote the presence of the HAPS Alliance at various industry events. And this event that we're currently holding now, organizing this event is another key thing that we do. On a regular basis, we use social media. We reach out to media and issue blog posts to publicize the activities of our member companies and their leadership. And looking ahead to 2022, we want to continue to build on that momentum, increase our presence and reach. We're looking to publish a third white paper to showcase advancements in the industry. And as Ken mentioned in his opening remarks, we very much, depending on the state of international travel, if possible, we'd like to hold an in-person conference as well, as networking, meeting face-to-face is a big part of being in an industry alliance. So just in closing, I'd like to say that in our working group. New members and ideas are welcome. If you're interested in joining or a current member, definitely look forward to participation and engagement. So I will hand over back to Alicia. Thank you very much.
Thanks so much, Matthew, and also thank you to Fatema and to Andy. You all three do quite a bit behind the scenes to really make the work of HAPS Alliance continue and thrive, so appreciate that. I would like to now turn our session into our portion on HAPS against action against wildfires. It's a portion of our webinar today that's of particular interest to me. There's been a lot of activity and interest in leveraging HAPS to mitigate wildfires. As a resident of Northern California, of course, this is a region in our world that's been impacted greatly by wildfires over the past many years. So very interested to hear what our panelists have to say about that, and I'd like to introduce them now. We have Dirk Giles, he's the UAS Program Manager, USDA Forest Service. We have Dr. Marcus Johnson, he is a Project Manager, Aviation Systems Division at the NASA Ames Research Center. We have Pere Roca, he is the Technical Director, Connected Intelligence for Airbus Defense and Space. And we have Russ Vanderwerf. He is Director of Engineering at Raven Aerostar. Welcome to all of you, and thank you for being with us today. We'll go through a presentation by each of our panelists, and then we will have a period of question and answers that we can ask to each of them. So I'll start with Dirk. Thank you so much for being here.
All right, good morning. Thank you very much. It's my pleasure to be here. So yeah, thank you for the introduction. My name is Dirk Giles. I'm the Unmanned Aircraft Systems Program Manager for the U.S. Department of Agriculture and Forest Service. So I was asked to come on and talk a little bit about what we are doing in wildfire management with unmanned systems. So initially, if people are not familiar with the USDA Forest Service, it's a fairly large organization. It's broken up pretty much in divisions and branch chiefs and deputy chief areas, but there's the chief office, which is mostly headquarters and policy. Within the national forest system, we've got over 155 national forests and 20 national grasslands, and it's really covering just about 9% of all U.S. land area across 44 states and Puerto Rico and Virgin Islands. So you can see in the map on the right, all those green sections are pretty much lands that are jurisdiction by the Forest Service. There is also a research and development wing to us as well that is really focused on science and technology to improve forests and forest health. And then state and private forestry, which is really that collaboration between private, state, local governments, forestry industry, but it's also the home to where fire and aviation management is at. We have business operations, the typical HR, CIO type of ops, and then very active international programs across influence and engaged in approximately 92 countries around the world. Kind of bringing it more towards what has the agency done with UAS. There's been some dabbling of the technology since the early 2000s. Most of those early engagements were one-off partnerships, either with NASA on their Icona project, or Customs and Border Patrol, or the National Guard, and then really just some small one-off demonstrations and examples of proofing out use cases. Ultimately, it led up to about that 2017, 2018 timeframe, where we were starting to integrate UAS into aviation policy. And then that really kind of led into 2018 when the program manager was officially hired. So looking at the foundation here, there's essentially 3 keystone documents for the program within the agency on this side. And it really kind of flows into the business case of what are we trying to build to meet GSA or other regulatory aspects of building an aircraft program. So then standards for operations, but more importantly to me was the programmatic risk assessment of what are we trying to do and where are we going with it. all of these will eventually evolve with the program as it matures. But looking at the programmatic risk assessment, in 2018 timeframe, it was just me and one person sitting in a chair. So I was really concerned and looking at how do we oversee and manage a program on a national scale across regional business. And so the risk assessment started to establish jobs that didn't exist to begin to start to be that organizational chain. So now we can start to oversee and manage. Pretty excited here in the last 6 months. A lot of these jobs have begun to get filled and start to engage. So really trying to bring this back to wildland fire. The Department of Interior and the Forest Service have a very aligned mission set. And so the Department of Interior's OPM, or Operational Procedures Memorandum, their OPM 11, and our Forest Service standards for UAS operations are very parallel documents. But then when we move into wildland fire, it's mostly governed by the National Wildfire Coordinating Group. And so we have these standards there that essentially control all operations. It doesn't matter if you're driving a water tender or an engine or a crew, helicopters or rotor wing or fixed wing. But this is the standard for UAS now operating within that space. Excuse me. So inside that NWCG, or National Wildfire Coordinating Group publication, which is known as PMS 515, there's how we type UAS. And so 1 being the largest, 4 being the smallest. Typically type 1s and 2s are contractor owned, contractor operated. And then the type 3s and type 4s are more agency owned, agency operated. And it's really kind of a, where does it fly within the stack of aircraft that we have over an incident, and how long can it stay there? Here's some visual representations of, type 1 and 2s and type 3s and type 4s of what we are using right now. So wildland fire is a big portion of our focus right now, but as we look at UAS, it's the agency's aviation program. And so how can we get that high resolution data for on the ground decision makers to make a decision right now? So the examples on the right are just some of the projects that we've been working on here in the last year or two, and in partnership with our partners across the interagency. So kind of bringing it to that wildland fire scenario, if we really look at our communication structures and how the procedures, I was asked to kind of represent something of how do we communicate within this space and within this use case. And so a lot of it's really done by fixed radio infrastructure, towers and repeaters. And then there's situational infrastructure. Say there's a fire that's going to be long duration or long term. We'll put up some portable repeaters so it can be expanded upon. So a lot of that radio communication is done over, so everybody's getting tactical knowledge sharing versus that closed loop, like a cell phone conversation. Making a tactical decision on a cell phone isn't necessarily the wisest path when engaged on these types of incidents. But we're really looking at transmitting voice, and I'm very interested in how can we start to move to transmitting data. And it's really just a situational sharing versus like a common operating picture, which is some initiatives on some other aspects within my agency as well. So some of our challenges, I think, looking at wildland fire and wildland fire management moving forward is connectivity in a disconnected environment. And then really looking at that connectivity solution, what are these emerging technologies, and are they in research and development phase, or are they operationally scalable right now? And so as we start to look at that, what are these standards going to be? And so between all the partners that engage on the wildland fire use case, there's over 640 interagency cooperators across the nation. And so as you begin to look at that scale, how can we start to influence that? And then really what it's going to be as well is a huge challenge is adoption. And so how do we engage that new employee, but also the seasoned veteran that's been around for many seasons? So some of the challenges that I've seen, that adoption with even just small UAS within this traditional airspace is how do we start to integrate safer within traffic management? So we've partnered with NASA on their Stereo project. It's a scalable traffic management for emergency response operations, and really trying to get to the point where how can we share or how can we see other aircraft in real time and space? So really trying to see if we can modernize the airspace that we're operating within. So kind of looking at our path forward, the Forest Service and our interagency partners we're going to remain focused implementation. So crawl, walk, run strategy, and it's going to be national oversight and management. And so we're going to continue our partnerships of our research and development and test and evaluation. Mostly that's really going to be focused on what is the field asking for and how can we deliver what the field is requesting. And so that'd be a challenge as we move forward as well, to see what does the field want versus looking at emerging technologies. And then really the path forward is it's going to be collaboration. So not just the interagency, but intra-agency as well. As we look at, say, a HAPS solution of connectivity, it's not just myself and my program for the aircraft, but there's going to be multiple other staff areas that have to engage. I know we were running a little short on time, so I tried to make that real quick. So I tried to give you a nice little ground view. Some of the scenarios that we were seeing on the left, it'd be, this is a view from a ground control station, and then what we're doing with small UAS within this space. Thank you for your time.
Thanks so much, Dirk. We will next turn it over to Dr. Marcus Johnson with the NASA Ames Research Center.
Thank you. Hopefully you can hear me.
Yes.
Okay, perfect. Let's see if my little thing works. Okay, thanks, Dirk, and thanks everyone for having me. Dirk set me up pretty nicely. So what we are looking at NASA, and the focus of this talk will be mainly on some of the R&D efforts and kind of how we're thinking about supporting some of the wildfire activities, and I'll kind of highlight some ongoing activities. I think Stereo was mentioned in there. I'll talk a little bit about that as well. I think you've heard so far about some of the other touch points to kind of HAPS platforms in development, whether it be on kind of the aircraft airworthiness side or on airspace integration side. So I'll touch a little bit on the airspace integration as well as an example. Okay, oh, it's gone. So just a little bit by the numbers. I think everyone can see in the news, well, it seems like almost weekly this summer, just the vast impact of wildfires. This is just a little snippet of some of the costs associated with it. So, total suppression costs were on the order of 2.35 billion over 5-year average. Just 20,000 fires over 10-year average and over 1 million acres burned. And then this year, there was, as of August, this is even dated, at least 34,000 fires and about almost 3.1 million acres burned. So, this is a big problem. NASA has been supporting the wildfire community for some time. However, we are also looking at, from an aeronautics standpoint, what more can we do? We do acknowledge wildfires do contribute to the broader climate change, and then climate change in turn increases the likelihood of wildfires. So this is an ongoing problem that we really need to have good solutions for. Sorry. Okay. Did it step through? Okay. So to that end, last May, NASA did kind of a needs assessment workshop to kind of get an understanding of what the state of the art was. So our aeronautics side of NASA, work together with our Science Mission Directorate and our Space Technology Mission Directorate, as well as in partnership with the Forest Service. And we conducted this workshop. We identified the needs and challenges of stakeholders of various decision cycles. And we went through kind of the broad range of planning, prediction, detection, tracking, mitigation, suppression, and then kind of that post-fire remedial efforts. There was a good cross-section of government, academia, industry, and certainly NASA folks there. And some of the main findings I think were very interesting. And those top two ones I think are the ones that I'll kind of focus on a little bit today. Really that lack of persistent surveillance for fire detection and tracking, and this lack of persistent communication. These two things are really very challenging, I think, when you go into these areas where radio line of sight is a challenge, and then just the complexity of the airspace and getting eyes on the sky. There's limitations, there's risk in putting piloted aircraft up. So those two findings I think really are very relevant for this community. I do want to point out there is a workshop report that you can find on our NARI site, NASA Aeronautics Research Institute site. So feel free to go take a look at kind of what was talked about in that particular workshop. But what these findings do help us with, at least from a NASA standpoint, both from our aeronautics side and our Science Mission Directorate side, is where we should put our research and development efforts to make the most significant impact. So an example of one of the known challenges that was identified in this particular workshop was we do rely very heavily on satellite detection for detecting and trying to monitoring fires. However, satellites are very limited in terms of their coverage and in the timeliness of the information that they provide. Typically some satellites will only provide basically 4 fire snapshots per day. A lot can change throughout the day. So getting something that again is more persistent is really needed. You can augment if you have access to some of the military satellites. You may be able to get a little bit more frequent than the 4 snapshots, but not every stakeholder has that type of access. Another platform that is used in wildfire operations is the National Infrared Operations Program, and this is really kind of one aircraft that's currently in operations. It does provide kind of IR imagery from an aerial platform, but this really gives you kind of a single nightly snapshot of the fire perimeter. So again, this need for more current information and need for the ability to port that information over to the decision makers is essential for kind of evolving how we address wildfire mitigations. Digging a little bit deeper again, that first set of bullets there just digs a little bit further into the detection, tracking, and surveillance. As I'd mentioned, there's infrequent satellite or aircraft observation. There's a notion of accuracy that needs to be addressed as well. The types of sensors that are used to actually give fire detection needs to be more precise, more targeted. There are development that needs to happen on the prediction models themselves. They're often unreliable. And just in general, better sensing, ability to see through clouds and things along those lines. And then there is this data overload problem where a lot of different information coming from different sources, right? And which data set do you trust and when? So talking a little bit about some of the research activities that are ongoing. And again, this is a snippet of what's going on just kind of within the time that I have. It was mentioned already, the scalable traffic management for emergency response. This particular effort was kind of born through a combination of 2 different efforts that were going on. One was our UAS traffic management concept and kind of technology development, trying to apply that to the wildfire use case, and kind of building upon some of the work that we had done previously with JAXA with their DNet system, which is kind of an optimization capability to optimize where mission assets go, both ground and airborne. So pairing those 2 things up gave us some insight that UTM could be very useful for disaster response operations. So we entered a collaboration with CAL FIRE and the U.S. Forest Service to start looking at how to start creating this common operating picture, how to start providing the awareness of where aerial platforms were operating in to allow better integration for the UAS into the operation. And if the UAS can be better integrated into the operation, they can be used as a tool to start shifting some of the risk away from manned operations. So we have been conducting some of these field tests, again, with CAL FIRE and the U.S. Forest Service, both piloted operations, live flight test operations, as well as some simulated operations looking at the inclusion of things like autonomy as well. At its crux, what we're trying to enable is really just a basic situation awareness. What is going on in the airspace? Trying to connect the dots between your air boss to between your UAS operators, between the tankers and the other aircraft that are kind of flying in that airspace. But as we start kind of creating more digital information exchanges, the need for communications becomes more prevalent. Using right now initially terrestrial communications, line of sight is a big issue. Particularly in environments where wildfires are happening, which often can be in these mountainous terrain environments. So communications, having something that's a broader communication architecture, which kind of can leverage HAPS platforms, I think would extend this the stereo technology even further than what it is right now. So this was mentioned by Andy a little bit earlier, but NASA is also doing research on what I would consider an enabler called Upper Class E Traffic Management, or ETM. And this is a cooperative approach to airspace integration and management. It's to try to enable that safe, scalable, efficient, and fair use of the airspace to accommodate all missions. What is interesting when you put it into the wildfire context is that you are going to have these points of interest in which have different mission objectives, whether it be surveillance, whether it be science, whether it be communications, right? And so many of these platforms are going to need to be able to, even though they're in the stratosphere, they're going to need to be able to kind of work these areas of interest to support wildfire operations. And this starts to scream traffic management, even if it's not at high densities. It starts to scream, you need to start coordinating, you need to have collaboration. So this research area is really just try to start to enable that. Right, and it looks at existing user needs, so who is already operating there, looks at what the emerging user needs are in kind of future demand. Again, for wildfire operations, it's going to be these very targeted demands in certain parts of the country, which will shift as the wildfire season evolves. But as we see, there may be a diversity of different aircraft characteristics, and so trying to plan out and coordinate amongst these different operators is really the intent of this. And then, having it interoperable with the existing air traffic management system, which again, this has its basis in what we did for UTM, but really extending and evolving that concept for this domain. Sorry. On our science side, this is just a snippet. Again, there is some considerations for observations in science. There is definitely, when we think about wildfires, there are kind of multi-mission needs. So not just having kind of one sensor per platform, but having something that can actually serve multiple missions that could be repurposed at various times within its flight. So beyond just fire monitoring, I pulled this from it's a little bit older workshop, but it's still relevant. There is many different uses for stratospheric platforms. I think many of those were kind of mentioned today. Anything from air quality monitoring, pollution tracking, weather forecasting, looking at the ozone, even to hurricanes. What we're focused on right now, at least for today's discussion, is more of the fire monitoring side. But our science mission directorate has a broader set of needs. And the general thought is this stratospheric platform could actually fit within something like a new observing strategy, which doesn't replace necessarily any of the lower Earth orbit types of observations, or even some of the lower altitude aircraft operations, but actually fits within that type of observation strategy and enhances the types of products that you're getting from surveillance or from different types of sensors. And so, this is very helpful, I think, in terms of paving out where the science needs to go in order to inform things like the prediction models for wildfires. I'll end on this one because I know we're short on time. A little bit of an eye chart, but we do have an ongoing collaboration in our Science Mission Directorate with Swift Engineering. This is looking at HALX, particularly looking at the kind of a sustained infrared imagery using a high altitude, long endurance platform, and really trying to put on a five camera type of imaging payload to be able to see through the smoke, be able to monitor, provide essentially an instant awareness and assessment, and look at kind of this notion of kind of multi-data collection missions during an operational flight. So be up there for a long time, look at, you know, wildfire prediction, wildfire monitoring, and then kind of post wildfire diagnostics or response. So I'll end here. I know that we're short on time, but looking forward to any questions or discussions. Thank you.
Thank you, Marcus. That's terrific. Next, I'll introduce Pere Raka from Airbus to give a brief overview about what Airbus is doing in this on this topic.
Yes, thank you, Alicia. Good morning, good afternoon from Barcelona, Spain. I'm Pere Roca. I'm a technical manager in Airbus Defence and Space in the business line Connected Intelligence. I have selected 3 Airbus experiences to share with you today, which are relevant to the forest fires context. And I selected them from a wider list of other activities that are undertaken in Airbus to enable services from the stratosphere, services that we want them to be as much reliable and scalable as possible. Yes, thank you for changing the slide. I am so the first experience I'm going to share is a joint experience between Loon and Airbus, in which we embarked an Airbus payload, optical and medium wave infrared, in a Loon HAPS. During that flight, we were monitoring the NASA's firm's webpage to observe if there was any fire event in the area where we were flying. And when we crossed over Arkansas, we detected 2 days old fire that we thought was worth to visit. So we tasked the HAPS to visit that location. We pointed our cameras there. We filmed what was there, and then this video was streamed and geo-referenced on the cloud. And what we obtained is what you will see in the next slide. We obtained what you see in the left panel. These spots clearly visible on the background. These are not actual fires. These are remaining hot spots from controlled fire which happened 2 days before. So when we shared this image with experts in fire extinguishing, they were I mean the feedback was really positive, because they admitted that some years up to 30% of the burned hectares that they are facing are caused by badly extinguished or supposedly extinguished fires, then they rekindle. The second experience I'm going to share with you is, in fact, the Zephyr campaign that we concluded in September this year. The main outcome I will highlight here is the fact that we could be flying in the national airspace system through an FAA approval. This is a big step towards the operationality of our platform to provide services. Also, I would highlight the high level of maneuverability of the platform, so that you can see how we were able to write the name of the company in the sky of Arizona, following very exactly the trajectories that we had expected. And the third experience is more in starting now. We don't want to go to walk this path alone. We wanted to do it with the forest fires community, and the European Commission issued a call that is really helping us to do that path together. The call was about making Europe more resilient against extreme wildfires. It's a consortium of 35 partners, most of them in the wildfires community from many states in the European Union and Chile as well, with a grant of 20 million euros. In this initiative, Airbus is going to propose HAPS service. And we are going to simulate how performant this service can be based on different inputs, as I'm going to show you in the next slide. This is how this simulation would look like. There is a constellation of HAPS flying in the southern Europe, what we call the Mediterranean Arch, which is the area which is more affected by forest fires. And there will be events, actual fires, but also high-risk areas or natural protected areas that we want to protect. And this will be calls for action for the fleet of HAPS. And the project consists in simulating how this fleet is capable of covering all these events popping up. Basically, the project will define what is the service. If the service is just providing connectivity to the local forces, extinguishing forces, or it is monitoring the fires, or it is detecting fires in a critical area. We also want to identify the sources. We know that Europe has the EFIS service, European Forest Fires Information Service, that shows the latest status of fire events in the continent, but we may need other sources as well. We will define KPIs to evaluate the performance of the service. And in the actual simulator, we will play with fleet sizing, so we can have a constant fleet size or a variable along the season fleet size. We will define rules. What is the priority to attend first fire, or if we have an aircraft following or just deployed in a fire, if there is something else more important, does it leaves that location and attends that specific fire. So all these rules have to be defined. Obviously, we'll have to face constraints, regulatory constraints, areas that we cannot overfly, and we will assess the KPIs. We will get best practices and conclusions, and we will define a roadmap for the European Commission to be able to adopt these services in the future. And I will finish my presentation with this takeaway phrase, which is flexible, persistent, and accurate HAPS constellations are taking off in the sense of that are starting to be ready to provide value to the wildfires community. Thank you.
Thank you so much. That's great. Then I would like to finally hand it to our fourth panelist that we have today, Russ Vanderwerf from Raven Aerostar. Russ, please.
All right, so we saved the best for last, I assume. So I'll talk just a little bit about what Raven's been doing in this space. This first slide is just kind of a lead in, and I think several people have expressed this idea already, but we do high altitude balloons, and we don't see that as the end all and be all, but we do think that in this area and a lot of areas, this is an important part of the overall picture between space assets, high altitude UAVs, and other sensors that are already closer to the problem. So what we can bring with the high altitude platforms is really trying to solve for a couple of those key things that the NASA and Forest Service gentlemen spoke of earlier, which are having a unique vantage point for providing communications. We know that in these applications that radio contact is limited, there isn't a lot of good comms infrastructure. And we, being at say 60, 70,000 feet gives you a great place to try to augment that. And then persistence. So as was already mentioned earlier, a satellite might come over 3-4 times a day. An aircraft is lingering for as long as the fuel holds out, apart from the solar systems that you've already heard about today. But with high altitude platforms and balloons in particular, we can linger over an area for days to weeks, which in the case of wildfires, I think can be really useful. So just a little bit on the balloon stuff, and I won't use this as too much of a soapbox before we move to the next slide. What the balloons provide particularly is the balloons are navigationally enabled balloons. So they are able to steer using wind layers and changing altitudes to catch different winds in the stratosphere. You can kind of see a picture down there at the bottom. This isn't a weather balloon, so we're talking carrying, say, 125 pounds up to 70,000 feet, and that's for payload, sensors, cameras, comms equipment. And then you can kind of see how it works there in an inset, and obviously I don't have too much time, but it moves up and down with a blower to control the altitude. And then the system is a battery stack that's solar recharged, so we can operate 24/7. On the right there, you can see a flight path, and that kind of gives you an idea of what's possible from the navigation perspective. So we're not propelled. We can't steer directly to a target, but we can stay within reasonable monitoring radius of a target over the course of multiple days, as shown in that little graphic on the right. That's a flight path from one of our flights. I'm going to press to the next slide, and we'll see if it works. All right. So talking specifically about fires, what this is actually a flight track and some bullets from some testing we actually did this summer. So, you know, our balloon system has been developed over the last almost 10 years and done some work in collaboration with the folks at Loon who spoke earlier. They were a strategic technology partner of ours in the balloon development. Then as well, the Thunderhead system, which is what this flight is from, is our commercially available system. We're on the order of several hundred flights with that system now, so it's a high technical readiness system. And this is footage from an actual flight that we did this summer. So this isn't something we're proposing to develop. It's something we've demonstrated, and we're now hoping to extend. So what you'll see in the background there, one of these balloon systems, which we flew just on internal R&D, you know, this summer, flew over several of these fires in western Montana and Idaho, and then eventually next we moved to that larger Dixie fire in Northern California. And you can kind of see a timeline and a flight path where we were overhead of several of these large wildfires over the course of about a week and downlinking data. And so we flew with this system. We flew an EO camera, which obviously had a lot of smoke obscuration, and then just a COTS IR camera. This isn't you know, MWIR or something that's more directly targeted for the application yet, but it was just to show as a proof of concept what we could achieve with the platform. And so what we're hoping to do, you know, with this flight is to show how this could be useful for somebody who's actively trying to fight a fire. So one of the things that was mentioned earlier in the needs and use cases section was tracking the perimeter. So where's the front of the fire, and how are we doing on containment? And so what you see in the upper right there, those are two images still frames that I just grabbed out of a series of frames from the IR camera that were captured about an hour apart. And the red area is just an infrared threshold that shows kind of the burn area. And so you can see that as that fire expands and progresses there in the little map in the upper right, that's about 900 feet of ground movement in about an hour. So then remember that this balloon was over that fire for the course of that hour, and in fact for several days. And so having this kind of persistent coverage, just even with a commercially available cheap infrared sensor, we think really brings a lot of utility. And this could be carried down in real time to those people who are trying to manage the situation. The other thing that we're working on, which I don't have a graphic in this slide because I know I only have 5 minutes, so I have plenty of graphics, but I put a few bullets on down below, are long-range comms. So we did demonstrations this last year, both of extension of long-range handheld tactical comms. So that was with an MPU-5 radio on the ground, where we were bridging between a couple of balloons and connecting people over about 200 nautical mile radius with the balloon as a comms backhaul or comms bridge. And then we're also working on a demonstration providing LTE coverage from the balloon. So that's another case where I know that it was mentioned that handheld radios are the primary source for communicating during these fire situations, but having LTE coverage, I think, could also be really useful for those who are trying to fight the fires. So these are things that we've done and are doing and intend to keep doing. So it's sort of not a concept, it's active demonstration that we're on. So the next slide is just wrapping up with where do we hope to go from here. So let's see if the magic works. Yeah, great. So we'd like to talk to probably a lot of folks on this call. So now that we're confident this is a real capability we can provide and we've demonstrated it, you know, how do we work with everyone to enable what you're doing? And so hoping to take some follow-ups from this and get some partnerships. Everything we've done so far has just been demonstrations on our own R&D to show what's possible. But we want to start integrating with actual practical systems. And so we're hoping for next fire season to have some demonstration partnerships with some of the entities that you've heard from today, as well as work with some of the sensor partners. We're not a sensor provider, and so our intention with this is just to take this stable platform. We've been building high altitude balloons for 65 plus years. We've flown multiple hundreds of flights on this system and thousands of flights on balloons, and then take that and put some of these sensors that can do more complicated things, like actually computing those fire perimeters and sending that down in real time or over SATCOM, or doing bridging, targeting comms for existing handhelds that the firefighters are already carrying. So that's what we're hoping to work towards next summer. And we're hoping then to integrate, and I think the vision would be to have a payload that provides both the camera and the comms that could linger for days to weeks over a fire, or in a constellation with balloons and other aircraft, even providing comms down to the aircraft and not just the folks on the ground to backhaul that data. So you can see my beautiful cartoon down in the problem there. Sorry, down at the bottom of the slide there. So we're excited about this problem space. We're excited to dig deeper, and that just shows some of what we've already done. And we're looking forward to working with everyone going forward. I think since we're out of time, I'll save the rest for Q&A, but if anyone has specific questions, I'll be happy to answer them.
Thanks so much, Russ. Really appreciate it. We are running short on time. I'd like to do the following. I'd like to take you through a few slides that we have that introduce some of the HAPS Alliance members and what they're doing on wildfire suppression related activities. I'll go through those pretty quickly. We'll ask for a few closing words from our Vice President, Greg Ewart. And then for folks that would like to stay on, I would like to extend the session by 10 minutes and have a quick Q&A of our panelists, assuming that our panelists could stay on. Panelists, does that work for your schedules?
Yes.
Yeah, I'm good.
Okay, terrific. So thank you for the questions that you've submitted thus far. We will continue the session for a few minutes, but I will take us now to, we have 4 members, Avialto, Kraus, Hamdani, Sceye, and Stratasys, that did provide some quick slides for us. Avialto is working on wireless infrastructure services, and we will send out a bit of information past the session to all that registered about what they have submitted in terms of their wildfire suppression infrastructure activities. Kraus Hamdani, same situation. We will send this information out. This is looking at their aerial fire management. A couple of slides here. Persistent environmental monitoring. Emergency aerial fire response. Apologies for going so quickly. We heard from Sceye a bit earlier. This is covering the full extent of a fire and their coverage here. And then finally, Stratasys, Earth observation activities, optimizing HAPS operations. So with that, if I could turn things over, we're going to skip the Q&A for now and turn things over to Greg Ewart for a few closing remarks. And then, as I said, we will switch back to our Q&A in just a moment. So Greg.
Perfect. Thank you very much. You know, I think as listening to all the presentations today and, you know, the speakers, one thing I continue to be excited about is the, you know, speed at which not only organization, but the ecostructure around HAPS and HAPS technology is advancing. You know, Ken talked a little bit about, you know, why we think this is important. You know, 3 billion unconnected or underserved folks in the world is not only a problem, but it's also a large opportunity for someone to, you know, crack that nut. I think the disruptive technology that HAPS presents, along with what we see are tailwinds with composite materials. I think some of the beamforming technology that we heard about today, the standards of 5G and 6G, ORAN, et cetera. These are all moving in our direction, not only through our efforts, but through around us. And, you know, really pleased with respect to that. And I think that's demonstrated in, a little bit of a shout out for, HAPSMobile and AeroVironment did a big test that they talked about with stratospheric platforms. Zephyr was up again with Docomo and NTT this year, and Sceye and, Prismatic BAE, who just joined. These are all, live tests that are proving out the technology. At the same time, we're seeing our standards and our working groups within, not only our organization, but some that they team up with, working on a lot of the integral parts that are going to be needed to, again, make commercial viability for HAPS a reality. So, working with ICOA, FAA, NATS, et cetera. I think the telecom group working with 3GPP, et cetera, is good. And then our marketing group that's pulling together the mind share that I think needs to be represented, so that we can not only educate regulators, but also the various elements of people that will utilize this technology. So as I look to, next year and the organization, what I see is us, shifting gears and moving more in towards what I call commercial reality, working with the key, MNOs around the world, or the key constituents that could use either the sensor networks, imaging networks, et cetera. I think 22 is going to be a year for, helping to get those business models in place, helping to get the regulations in place so that we can start to prove out the technology and connect the 3 billion that we talked about. In closing, I just want to, number one, thank everyone today, the panelists, and also the people that are participating, just to listen in and educate themselves. I look at them as spreading the word too, and I think that's very, very important. And with that, I will pass off because I know there's some other questions and comments. But as we said at the beginning, the HAPS Alliance is open for business, new membership, and anyone who would like to join the organization, we would love to talk to you about that. So thank you very much. And again, thank you for all the participants today.
Thanks so much, Greg. Appreciate it. Panelists, I've got a few questions here that I'd love for everybody to address. First one, what data science can be collected from stratosphere that could be useful for mitigation to support wildfire prevention? Marcus, I think that one probably goes to you.
Yeah. So I'll make some comments on it, but again, this might be more for our Science Mission Directorate expertise. So from a data science perspective, there's certainly some of the visible imagery, some of the IR for monitoring. There is kind of a number of different types of visual sensors that I think provide the robustness of information. Whether it's kind of the long IR or what do they call them, the millimeter wave. So yeah, I think there's a wide suite of different types of technologies. I think one of the things to consider is just some of the challenges that are associated with running these missions and kind of the different requirements around different types of measurements. If we have a single platform that can do a wide variety of, have a wide sensor suite, the requirements on the mission itself may be different. The altitudes, the time in which they're suspended in a certain area versus maybe even having to change altitudes to get a different perspective. So yeah, I know it's kind of a roundabout answer, mainly because I'm not as much on the science side, but hopefully that gave some insight.
That's great. Thank you, Marcus. Understanding that HAPS can provide both imagery and connectivity services, which of these capabilities would be suitable for the different fire phases, namely pre-fire, during fire, post-fire? Dirk, wondering what your thoughts are on this.
Yeah, that's a good question. I'm pretty selfish and I'm going to answer it for what I would like. But I think connectivity. If we look, a lot of our sister agencies or our cooperators our state agencies, if you're in that lower lying country, there's usually some form of connectivity. Then when you move up into the more forested or less populated areas, there's no connectivity. So how can we push data in real time to make, not only make decisions off of it, but get it that data in real time enough to make on the ground timely decisions for that decision maker in time and space. And so that's going to be pre-fire with collecting whatever the imagery that science area is looking for, and then during the incident, so we're all operating on a common operating picture. And then post of what we're looking at is how do we stabilize the soils? What are we looking at from an erosion aspect? I mean, after the fires, just another emergency that started. So I would say connectivity, but if you bring in a lot of our geospatial folks, they're going to be looking at products that they would like to have. But I think if we had timely communications, we'd solve at least an 80% solution.
Thanks, Dirk. Well said. And I think, on that connectivity theme, constellations involving different types of systems will have to be managed as part of an integrated ecosystem. How do we guarantee the same quality of service in a persistent and consistent way? Persistent meaning continuity of time, consistent meaning continuity in geography. Russ, I'm wondering what your thoughts are on this.
Yeah, for sure. So this is one of those areas where there's actually a hidden benefit that people might not see, because both balloons and airships and stratospheric UAVs are really all dependent on what the wind conditions are at altitude. And so the more assets we have up there, the better information we have for planning, navigation, and persistence. And so, we've been working with other stratospheric providers to try to get data flowed in out of a common wind model. And I think as you get that constellation of assets up there, that's really where you approach more persistent coverage. The other thing, I'd say is that you don't need 100% persistence to be useful. And so in a lot of applications, I think we do not have a good solution for either comms or imagery 24/7 today. And so the more we can do and the more we can provide with the more assets that are successful in this space, the better we can make the situation for those on the ground who are really, fighting the hard battle. So those would just be a couple comments on that, I guess.
Super. Thank you, Russ. How do we integrate HAPS with existing technology solutions, and which countries are easiest for HAPS to carry out test flights regarding air regulations? Perry, let's start with you on this one.
Okay, so if we talk about integration with existing technologies, and we talk about, for example, satellites, which is a well-established technology, you have seen in my example before that we have been using satellites for sourcing where a fire was, and then comparing what we captured with a new image or fresh image from our own Pleiades satellite to get some conclusions. But technologically speaking, we are, and speaking about Airbus specifically, we are a space company as well. So we are drinking from or benefiting from our background in satellites, in the payload construction, in the telecommunications. So everything we do in terms of generating these new services, we have the background of the satellite. If we look also at the delivery to the end users, we are not really concerned about our interoperability with the end user systems, because the geospatial wall, and we are managing geospatial data, is highly standardized. Maybe the only point that would be or need some more development or more acceptance is georeferenced video at the moment. There was another question, I think, for me, which was the best countries that are
right.
yes.
Geographically, what would be the easiest in terms of carrying out test flights, air regulation wise, that kind of thing. I'm not
yeah.
sure.
Well, we have seen that obviously we have done a big step this summer in the US, so being able to fly in the National Aerospace System. We have already had the previous experience in Australia as well, which is quite open to this kind of flights, and we are working to have this possibility as well in Europe as soon as possible.
Thank you so much. In closing, Dirk and Marcus, putting you on the spot. I hope not too awkwardly, but we have many companies in the audience working on HAPS solutions today. If you have a call for action within the HAPS industry, what would that be?
There, go first.
Thanks, buddy. I think it's the big one. You know, we're looking for, we need operationally scalable. And when I'm talking operationally scalable, it's from New York to Hawaii. And, you know, if we're getting 40,000 fires a year, how can we manage? How can we respond? We already do have some built-in processes and procedures where I think eventually we can start to integrate it. So as like the planning levels for our response starts to scale, then maybe 1 launches or 2 launches, and we can start to spread them out geographically. But I think in the beginning, I'm going to have to really leverage the science agencies like NASA to really proof out the use case before that acceptance is going to become, because when we're looking at either a connectivity or a data collect, it needs to be proven effective and timely. So until we can really show that we can do this in real time and that it's done safe and effectively, it's going to be an R&D thing versus operationally scalable.
Great, thank you. Marcus, any thoughts?
Yeah, I'll piggyback a little on. So one of the key things I think, you know, from the R&D perspective is making sure the platforms are stable, can operate over people safely, right? I think it was mentioned, you know, means of compliance, making sure that they're in the U.S. There's a path towards getting, you know, Part 23 type certification. So you know, even before you start talking about, you know, what type of mission or data these things can provide to the operator, to the stakeholder communities and wildfire specifically, you really need platforms that are going to be reliable. So what you know, 10 to the minus what, right, reliability are we going for here, and making sure that that's something that you know, we can leverage. In once you have that platform and the certification case built for it, a lot easier to kind of go and build to different types of applications, different type of operation. The second piece of it is really that airspace integration. And you know, once, if you're trying to do this more routinely, if this is every fire season you're trying to get up, you don't want getting the aircraft in the airspace a limiting factor, right? That should be kind of a business as usual type of thing, as opposed to like a waivered process. So you know, focusing on those 2 areas starts opening the doors for having more sustainable type of business, and being able to, for wildfire, to be able to meet the needs of the operators who kind of assume that that's already taken care of to some extent.
Thank you, Marcus. Certainly a lot of important work to address coming up here. I know that we're over time. I so appreciate all of you staying a bit. Thank you to all of our panelists. Thank you to our attendees today. We look forward to continuing the discussion for future HAPS Alliance events. Appreciate everyone's attention today, and good day. That wraps us up for day 1. We have a member session tomorrow. Goodbye, everyone.
Bye-bye.
Thank you. Bye-bye.
Bye. Thanks.